Right. Now we'll see how to work on this. Right here, computer without graphics processor, computer with graphics processor co-processor. Now these are two different things. Very first thing is without a graphics co-processor. The other one is with a co-processor. What is telling? It's telling three steps. At a glance, you could be able to see it here. This is the main CPU. The CPU calculates each pixel value, performance, bottleneck. Here works out general information about display, free to do other work. This is the CPU. All display data details pass to video board, performance bottleneck. Transfers general information far as than with conventional video board. Free to transfer other data. This is the expansion buses. The last one is the different one. Video board displays information, graphics accelerator, intelligent board that coprocessor calculates each pixel value and displays it freeing main processor. These are two different things. What you understood? What you understood? Nothing. Nothing, right? You haven't understood anything. How to learn them? Nowadays, we'll see how to learn them. Now, I haven't understood anything. Assume like you, I haven't understood anything. What I'm going to do, I'm going to learn computer without graphics processor. I'm going to my favorite. Uh, where's my browser? Browser is missing. Go to the browser. Right. I'm going to the YouTube and I'm going to search computer without graphic processor. Right. Do I have anything? Computer without graphics processor. Right? No proper answer. No proper answer. No proper answer. No. No proper answer. No. No, right? Not even YouTube. Right? Then we'll go to our favorite one, ChatGPT. Then we'll ask question. How to solve this question? I don't know. I have a question. I'll ask the question. Now it's telling a computer without graphics coprocessor, also known as GPU processing unit, would rely slowly on computers processing etc. processing unit to handle all graphical computations. This means that CPU would have to handle both traditional computational tasks such as running applications and processing data, as well as graphics processing tasks such as displaying images and running games. While it possible to run computer without graphic coprocessor, the performance of graphics processing would be significantly reduced, especially when running graphics intensive applications such as 3D games or video editing softwares. Right now, I got something, or I did something that related to graphics. Right, if it is the graphic processor is not in there, that means it might affect for the performance of my computer, especially once it comes to graphic related stuff like videos and video games, like kind of a thing. You got it that one? Right. Now, this because the CPU is not optimized for graphic processing. And now we got some additional information. CPU is mainly focusing on processing ones and zeros, not to process graphical information. Right, we got something more, and it may struggle to keep with the demands of these applications. Now CPU might get into a big problem. However, there are some low power, low cost computers that do not have dedicated graphic cards integrated or integrated GPUs. These computers are typically designed for basic tasks such as web browsing, email, word processing. Now, some of low power, low cost computers. Whenever low cost means that do not have a dedicated graphic cards or integrated GPUs. These computers are typically designed for basic tasks. All right. Now we divide into two parts. Very first thing is we understood, all right, if there's a graphic processing unit or GPU, that means it's mainly focusing on upgrade the graphic work. But without the GPU, still we can work very well. What are the things that ordinary things like browsing, typing something, likewise? We understood that, right? So we understood what is a graphic or the graphic processing is and what happens if it is in there. We understood if this is not. Now, what is if it is not in there? We understood, all right, some understanding we got. Now, do not require the graphical graphics. In these cases, CPU may alone be sufficient for the computer's needs. Yes, obviously, if there's no specific videos, games and stuff, we don't want a GPU specifically. But if it is basically focused on very high-end graphic work, then we want specific GPUs. We'll see again, we'll go to the slides again and we'll see what is in there. Now, this is the computer without graphic core processor. That means there is no graphic core processor, but in here we have a graphic core processor. Now, we'll see according to this explanation what is the missing part in here. Both do have CPU, both do have expansion buses, and one is do have video board, the other one do have graphic accelerator. So this is the point that you need to understand. Oh my god, this is the computer with graphic core processor, means there's a specific graphics accelerator that there is. What's the purpose? The purpose is for videos and game development and other stuff. Clear? All right, we understood something. Now we'll go to Google Scholar. Right, we'll go to the Google Scholar and we'll read one article now. All right. We'll go to the Google Scholar. Right. Now we'll see some interesting stories in here. A case study. Now we'll learn a case study if there is. Computer hardware accelerators in scientific applications. A case study, 2010. Well, if we have something since 2019, well, blockchain processing might be hard. Quantum machine learning, bit hard sometimes. Teaching high performance computer development, not really. Bit hard to find. Applications of GPUs for signal processing algorithms. I think that's good. And there's a PDF. Yeah, we can go for the PDF. All right. Now the interesting time comes. Now we have initially very basic information. We go for my very favorite, what we call this video host. It's not providing something. Now then I have go my one of another favorite. Then I have go to another very favorite Google Scholar. Now it's telling applications of CPU signal. Now I want to read from here to here to here to here to all the things very well. Now we understood something, so we'll search some more things. GPU and CPU working together. We'll see, is there something that we have some explanations in here, and we'll go for one of interesting video in here. We'll see how computer memory works, GPU versus CPU. Right, we'll come to this one. and we'll see what is in there.
How's it going, everyone? Welcome to another video. Today we're going to be discussing the differences between a CPU and a GPU.
We have much more high definitions. We'll go to that highest definition. Will it work? Nice. We'll see this
So
video.
let's begin with making sure you understand what CPUs and GPUs are. The CPU, as most of you might know, is the central processing unit and is that expensive metal square you place in your motherboard, which is basically the brains of your computer. GPUs, however, are most of the time misunderstood a little bit. The terms graphics card, video card, and GPU are often interchanged to mean the same thing. This is true for the first two terms, but we have to draw the line at that third one. The GPU is the actual chip on your graphics or video card. This is an important distinction because graphics cards are made up of the GPU, memory, called VRAM or video RAM, and their own cooling systems. Many graphics cards can actually share the same GPU, but not the other parts. So you can see the graphics card itself is like a small computer within your computer. It has its own processor, RAM, motherboard, cooler. So what is the difference between the processor in your graphics card and the processor on your motherboard? To understand the differences, we need to look at the type of task each will be performing, because these are wildly different. The CPU has to perform a wide range of tasks for the entire system. These processors are great for serial tasks. This is switching from different things back and forth as needed. The GPU has a narrower range of tasks, though, with specific specialized areas of work. They are great for highly parallel repetitive tasks. These mostly include mathematical calculations for images and videos. If you've watched my other explained videos, you know how much I enjoy using my metaphors. So for this one, I like to think the CPU is a chef and the GPU is one of the chef's prep workers. The prep person is great at dicing up all the ingredients needed for the cook. They can cut thousands of potatoes, tomatoes, carrots, onions super fast, very similar motion, but they are the best at it. Meanwhile, the chef has to take these parts and mix them all together, use the correct temperature, timing, and mix them in the correct order. And in this scenario, of course, the chef can also do the same work as the prep person, but it's much more efficient to offload that work onto someone who specializes in it and can perform it faster. The CPU will take tasks like this for images and videos and send them to the GPU to deal with, since the GPU's architecture is designed for more parallel tasks. Speaking of architecture, let's go over the physical difference of these two chips. Where CPUs will have the advantage of larger pools of cache memory, GPUs have a huge advantage in the brute force of their thousands of cores. So for an example, a modern CPU, say the Ryzen 5 3600, which is a 6-core CPU, or an i7 10700K, which is an 8-core CPU, are typical CPU core sizes, 6 to 8. There's even some super high-end ones that go over 20, but that pales in comparison to the amount that's in, say, a 3080. A 3080 has 8,704 CUDA cores that it has to work with, and a lot of these are done parallel processes, all doing different calculations for the same thing at once. And just to compare that to an older graphics card, a 970, which was 2 to 3 generations ago, still has 1,664 CUDA cores. These cores, while they might act differently than CPU cores, do what they need to do for the GPU. So the difference is the CPU core will have many different tasks it might have to do, where the GPU core is basically doing the same exact specific task over and over and over. So they are, in a way, simpler cores, but you just have a massive amount of them just to push this work through. And that is all I have for you guys here today. I hope this kind of helped you understand the differences between these two processors and the advantages and disadvantages of both of them, but they work together to create what you see today. And if you have any other questions, leave them below in the comments. I'll get to them there. Otherwise, please consider
Understood something. Not really. Understood something. Now we can write